Alright, ladies and gentlemen, welcome to another Math Minute with Mr. Ellis. Today we're going to talk about linear equations. Solving them. What are they? How do we do them? Well, they're not bad, kids. And this is how we do it. We can see the equation x minus 15 equals 22. In general, our goal is to isolate a variable, to solve for a variable, to get it by itself. In this case, x is our variable, and we're going to get it alone. To get x alone, we have to undo the other number that is with it. In this case, it's a negative 15. So, in order to get rid of a negative 15, I must do the opposite to it. The opposite of subtracting 15 is, very good, adding 15. What I do to one side, I do to the other. Now it's time to actually simplify. I have a negative 15 plus 15. Thinking of my number lines, negative 15 plus 15 gives me 0. Big fat 0. I don't need to write a 0. Anything plus 0 is the same number. So, we say that these cancel out, leaving us with x. On this side of the equal sign, we have 22 plus 15. Using my calculator of a brain, I get that this is 37. Now, x is alone, it's been isolated, we've solved for x. That is the answer to our problem.
Welcome back. Let's try another problem. So this time, instead of doing an adding or subtracting, we have a division problem. So we have to undo a division problem. Just like adding and subtracting are inverses of each other, or opposites, we have multiplication and division that are opposites. So I have x divided by 3 equals negative 5. And just like the last two, we're trying to get our variable x by itself. So to undo my division, I need to multiply by 3. So I'm going to multiply by 3. What I do to one side of my equation, I must do to my other. Since I have a multiply by 3 and a divide by 3, these cancel out. But unlike with adding and subtracting, they don't cancel out to 0, they cancel out to 1. So again, I am just left with my x, or my variable. And then simplifying on the other side, I have negative 5 times 3, and using my math brain, I know that 5 times 3 is 15, but because one of my numbers is negative, I have a negative 15.
Oh hey, I didn't see you there. Let's jump back into a little bit of a harder example. We don't have just one step, we have to take multiple steps to solve. Our goal is still to get x alone. Right now, I have a negative 2 multiplying to x. I also have a 7 being added to x. We need to take care of these one piece at a time to get x alone. We are going to go from the thing that is furthest away from x, is what I like to think, to get it alone. So the thing furthest away from my x is this plus 7. I need to get rid of plus 7. We've talked about this before. We subtract 7 on both sides to get rid of the plus 7. Let's start by subtracting 7 on both sides. And then we'll simplify. Now, the 7 can only be taken away from this 7. We cannot combine this with this because they are not like terms. The 7s will cancel out, leave me with negative 2x on the left side of my equal sign. My equals. Over here, I need to simplify 12 minus 7. I get 5. Didn't need a calculator for that one. I now have a negative 2 being multiplied to x. The opposite of multiplication is, anyone? Anyone? Division. So I'm going to divide by negative 2. What I do to one side, right, we do to the other. Our negative 2's, negative 2 divided by negative 2, well, negative divided by negative is a positive, 2 divided by 2 is 1, 1 times x is just x. So it's generally said that these two cancel each other out, leaving us with x. On this side, we have 5 divided by negative 2. You have a couple of options. You can either leave your answer as a fraction, negative 5 divided by 2, or we can use a calculator and change it into a decimal. 5 divided by 2 in my calculator Ah, it's 2.5. Both of these answers are correct. It will be up to you to read the instructions to figure out what you're supposed to do.
Well, hey there. I'm dizzy, but that's not going to stop me from doing this math problem here. Look, we have another linear equation. Now, you have a fraction here. Now, I know everyone's scared of fractions, but don't be. We'll do it in parts. So once again, our goal is to isolate the x. So over here, you have division and multiplication, not just a fraction. So when we are dividing by 5, the opposite of dividing by 5, that's right, multiplying by 5. So we're going to multiply by 5. And what we do to one side, we do to the other. Now, the 5's cancel out, leaving you with negative 3x equals 6 times 5, 30. Now we're still not done yet. X is not alone. So the opposite of multiplying by negative 3 is dividing by negative 3. That's right. And what we do to one side, we have to do to the other. So here, once again, the negatives 3 cancel, leaving you with an x equals 30 divided by negative 3 is negative 10.
In 2 weeks, you will be assessed on the skill. You now have 10 minutes to complete the problems you have been handed.
A little longer than a few minutes later.
Your 10 minutes are up. We're going to go over a few problems to make sure that you understood what you just did, or at least understand the answers that are correct. Let's take a look at question number 2. If k over 3 is equal to k plus 2 over 4, then solve for k. Again, we want to get k by itself, but this one's a little bit trickier. We have a k in this fraction and a k in this fraction. So, the best way that we're going to solve this is by multiplying each side by the other one's denominator. Some of you might have called this cross multiplication, but that is a little bit taboo in the math world. I'm going to go ahead and do that. We're going to multiply this side by 4, and I'm going to multiply this side by 3. Now, leaving it like that doesn't do us any good. We actually want to multiply. 4 times k gives me 4k. We're going to copy our equal sign because we're moving on to the right side. We have k plus 2 times 3. 3 times k plus 2. Because we are multiplying a binomial, meaning 2 terms, by a single number, we need to distribute our single term in. We're going to distribute 3 to k and 3 to 2, giving us 4k on the left still, and on the right side, 3k plus 6. Now it's starting to look a little bit easier to get k by itself. I want to move all of my k's onto the left side. I see that there's already a k over here, so I'm going to make this one join the party. We have a 3k being added to 6, so I know the opposite will get it onto the other side. I will subtract 3k. What I do to one side of my equal sign, I do to the other, so I subtract 3k. What this leaves me with is 4 minus 3 giving me 1k. We normally just call that k. 1k is the same thing as k. On the other side, 3k minus 3k is 0. We do not need to write the 0, but we do have a 6 remaining. Oh look, k is by itself, and k is 6. That's c, and I'll see you later.
Alright, so guys, we're going to try example number 3 now and walk through it with you. Now pay attention. For the most part, this is just order of operations, PEMDAS. Alright, so for those of us who forgot, PEMDAS, parentheses, exponent, multiplication and division, adding and subtracting. So we're going to do inside the parentheses here first. So there's adding and dividing. Well, according to PEMDAS, multiplication, division comes before adding and subtracting. So we're going to divide these two first here. And we're going to rewrite it. So -3, parentheses, x plus 6 divided by 2, 3. Right? Now we're also allowed to do this out here, exponents as well at the same time. So plus 4, because 2 squared is 4, times 3. So I rewrote it, and now we're going to continue to do PEMDAS, slowly trying to whittle this down until we find a choice that looks similar to this or that we can narrow it down more. All right, next, PEMDAS again. I'm going to distribute. Distribute means multiplication. And then at the same time, I'm also going to take care of this multiplication at the same time. So I get -3x minus 9 plus 12. Now it's at this point here, I'm now on to the adding and subtracting because that's all that's left. So I have to combine like terms. And the only like terms are -9 and +12 because they do not have an x. There is no like term for -3x. So I combine these two, giving me 3x, -3x plus 3. Okay? Now, it's at this point where I would then, if I look at my answers over here, I see that they pulled out a 3. Well, by coincidence, heck, I can pull out a 3. So I'm going to take a GCF, greatest common factor, of a 3 out. -3. -3, x minus 1. I took and divided each of these by -3 to get this answer. Now, if I go through these answers here, I notice none of them match up perfectly at all. This one's missing the negative outside, but it's oh so close. This one It's x and 1 are switched. So this is the right answer, but it doesn't look the way they want us to look. So a way to get around this is to use our multiple choice and distribute each one of these to see which one would look like this or have these same numbers and variables. All right, so my first one, A, would be negative 3 plus 3x. B would be negative 3 minus 3x. C would be 3 minus 3x. And D would be 3 plus 3x. Now, even though it's not in the same order, right, I'm allowed to switch these because of the commutative property. 3 plus 3 minus 3x. So which one of these match up? The answer is C.
Okay, now we're going to try example 6. Just like with our last example, we have to use PEMDAS to simplify this and then solve for x. So parentheses, exponents, multiplying, dividing, adding, subtracting. So I've got my parentheses up top, x plus 6 divided by 2, all divided by 16 equal to 1/2. So I'm going to start inside my parentheses and simplify as far as possible. Multiplying and dividing comes before adding, so I can do 6 divided by 2. 6 divided by 2 is 3 over 16. Still equal to my 1/2. At this point is where PEMDAS is about as simple as it gets because we can't do anything else to simplify this fraction down. So we're going to have to go back to our previous examples where we had these fractions and we're going to cross multiply. But in this case, because I have a 1 up here, my 16 can just multiply across and I don't really have to worry about my 2 because we can simplify him later. So I'm going to bring my x plus 3 down, equal to 16 times 1, still divided by 2. And now we can do our division. 16 divided by 2 gets us 8. Now our x plus 3 is almost 1. We just have to get rid of this plus 3 to get our x by itself. So I'm going to undo the plus 3 by subtracting 3. What I do to one side, I do to the other. Plus 3 and a minus 3, well, 3 minus 3 cancels out. I don't need to write the 0. And 8 minus 3 gets me 5. I check my answers. I see A is 5, so our answer is A.
Next, we have example number 7. Z divided by 2 minus Z divided by 3 equals 16. But we have fractions. No, just kidding, they're not that bad. We need to subtract these two fractions. We want to simplify as much as possible, trying to get these Z's into one nice little gift package before we start solving, excuse me. So, I'm going to subtract these fractions. In order to subtract fractions, we have to have a common denominator. That is the same number in the bottom of each fraction. I look at 2 and 3 and I think to myself, what can both 2 and 3 fit into? I go through my 2's and my 3 tables, and I figure out that 6 is the smallest number that both 2 and 3 fit into. The way I turn 2 into 6 is by multiplying by 3. Whatever I do to the denominator, I do to the numerator. Before I simplify, I'm going to change my other fraction as well. 3 times 2 would give me that 6 that I was aiming for. Whatever I do to the denominator, I do to the numerator. This gives me 3z over 6 minus 2 times z is 2z over 6. Now that I have a common denominator, I can go ahead and subtract. 3z's minus 2z's is 1z, or just z. Easy. My denominator remains 6. What I've done is simply simplified the left side. My right side I haven't touched at all. So what I get is my simplified answer, z divided by 6, is still equal to 16. And from here, we want to isolate z. I notice that z is being divided by 6. To undo division by 6, we multiply by 6. What I do to one side, I do to the other. My 6's cancel out, leaving me with just z on the left. And on the right side, 6 times 16 is 96. It looks like z is alone, so I go back to check my answers. And here we are. Our answer is D.
All right, guys, we're going to do problem number 10 now. Now, this one is very word tricky, so make sure you try and follow along. Now, try and label the words that represent the operations I'm expressing. All right, so the first part here says, we'll read the whole thing. 1,000 is the result when 365 is subtracted from a number that is increased by 5 and then multiplied by 13. What is this number? So we have to get an equation based on the word problem here. And then once we get the equation, we have to solve for the variable that's missing. So let's tackle this first part here. It says 1,000 is the result. Well, 1,000 in the result, that implies an equal sign. So my equation equals 1,000 because that is the result. That's my answer. All right. When? So this implies that something's happening before it. 365 is subtracted from a number. Well, this word number implies an x or a y or a z or whatever variable you want to use. So right now I have x minus 365. Now as I keep reading, it goes, that is increased by 5. So that means that, well, x plus 5 happens first here, right? Because of the word that is increased by 5 and then multiplied by 13. So increased by 5 plus 5 and then multiplied by 13 is pretty self-explanatory. The 13 goes out front. Now that I have my full equation, I can now solve for x. That's my goal, that's my number, and I hopefully will get one of these answers on the side. First thing I'm going to do is I'm going to distribute. All right, this will allow me to get rid of my parentheses and combine like terms so I can start moving numbers back and forth. All right, so I will get, when I distribute, 13 times x, 13x, 13 times 5 is 65, and then the minus 365 comes down, and as well does the 1,000. Next, I combine like terms over here because it's easier to move one thing over than trying to move two things. So I'm going to combine like terms here. So 65 combines with negative 365. So this gives me 13x minus 300 equals 1,000. Right? Next, I still have to solve for my x. All I did so far was simplify it so I had less numbers and combined like terms. All right? I'm going to solve for x. I got to do inverse operations, so I have to do inverse PEMDAS. So I have to add 300 because the opposite of subtracting 300 is adding 300. These cancel. What I do to one side, I have to do to the other. This gives me 13x is equal to 1,300 now. Now the x is still not alone, and it's being held together by multiplication. And the opposite of multiplication is division. So divide by 13, what I do to one side, I do to the other. And 1,300 divided by 13, x equals 100. That is my number. So now I come over here, the answer is D, letter D.
Brandy's bank balance initially was $1,600, but she spent money at a rate of 20% of this amount every day. After how many days will she have a bank balance of $640 in her account? So again, just like the last example, we need to go through and break down what this word problem is telling us. So she initially had $1,600. That means she starts with this much money. But she spent money at a rate of 20%. Spent money. That means she's losing, that's subtracting. If you're spending money, you're giving up your money to somebody else. At a rate of 20% of this amount every day. Now the big key word here is 20% of this amount. She's not spending whatever she has left over, she's spending 20% of 1,600. Now, we can't plug a percentage into our problem, so we must change it to its decimal equivalent form. Well, Changing a percentage back to its decimal isn't hard. We just move the decimal 2 places to the left. So I have 1600 times 0.20% every day. We don't know how many days it is, so that's where my X came from. And after how many days will she have a bank balance of $640? So her new balance is $640, so we want to find out how long until she gets down to this point. So we have to start multiplying. PEMDAS multiplication comes first, so I have 1600 times 0.2. Longhand multiplication. I have a 0 times 1600. Well, doesn't really matter, it's a 0. All that's telling me is I have a nice placeholder 0. So now I can start multiplying by 0.2, or by 2. 2 times 0 and 2 times 0 gets me 2 more zeros. 2 times 6 gets me 12. So I have a 2. I bring my 1 that I'm carrying over. And then 2 times 1 gets me 2, plus the additional 1 gets me 32. Now this seems really big, but I have to take care of my decimal. I have 2 decimal places from my guy here, so I move my decimal 2 places to the left as well. And my final answer of 1600 times 0.20 is 320. We could sit here and subtract the 1600, but because my X is negative currently, I can go ahead and switch him to the other side to make him a positive number. It'll make it a little simpler down the line. So I'm going to add the 320X to what I do to one side, I do to the other. Negative 320 plus 320X, they will cancel. So I have my 1600 equal to, my 640 is not a like term with my 320 because my 320 has an X, the 640 does not, so they cannot combine. And now we're back to just a 2-step simple equation. My 640 is positive, so I'm going to subtract it. Now, this might look ugly, but you can do a quick simple math. I have 1600, I'm taking 640 away from it. Well, I know I'm taking away a complete 600, so my 6's technically cancel, and I only have 1,000 left over that I need to take 40 away from. If I have $1,000 and I'm spending 40 of it, I have 960, equal to my 320X. Our X is attached to our 320 by multiplication, so to undo this, we do the opposite, which is division. What I do to one side, I must do to the other. I'm going to bring my X over here for our final answer. Now we have 960 divided by 320. Coming up here for some extra room. Now another quick little trick about division. If both your numbers have a 0 in it, you can technically get rid of both. So instead of doing 960 divided by 320, I can do 96 divided by 32. So now I'm looking for a number to get as close to 96 as possible. The general trick is look for what can make your first numbers close. I have a 3. To get to 9, I need to multiply by 3. So I'm just going to multiply by 3 and see how close this gets me. Well, 3 times 3 gets me 9. 3 times 2 gets me 6. I hit the nail on the head, so I have everything canceled out. And our final answer is X equals 3. Coming over to check our answers, we see our answer is C.
We hope you enjoyed this little video explaining some of these problems. If you have questions on the rest, you can come see any of your math teachers, and I mean any of them, and we'll be able to help you out. I have after-school tutoring on Thursdays. Mr. Nowak has after-school tutoring on Tuesdays. Remember to hold on to this packet. You will be tested in 2 weeks. The whole school will be tested in 2 weeks on this concept. Make sure you know it before then, because if you snooze, you lose.